Please be quiet. Those of you who are gone, the expectation is that you have watched the video, which I would be willing to guess you didn't, which I don't even want to know because I will be so far mad at you. It's not even funny. So just to review, in your notes, your regular old notes, which you should have, we have talked about ways to estimate the definite integral. There you go. Okay, first of all, what is the definition of definite integral? Two definitions of definite integral. Mason, stop talking. Two definitions of definite integral. What's one of them? Area below the curve. What's the other one?
X times y, where y varies.
X times y, where y varies. Okay, so we're doing multiplication. It is the area underneath the curve. It's x times y as y varies. We've talked about now 3 ways to get this. Okay, what's the first one?
Count the boxes.
Count the boxes. Yep, that's the first one. Okay, what was the second one that we talked about? Rectangles. Trapezoids. Yep. Okay, and then the third one? Rectangles. Okay, so I believe that the last thing we talked about on your paper was this, right? These notes?
Yes.
So what happens the more rectangles you have? What happens to your Riemann sum?
More accurate.
It's more accurate. Okay, so the more, this is why, you guys, this is why we have to do limits, and that limits are the foundation of everything. Because as the limit of that dx, which is the width of the box, as the limit as dx approaches 0, your Riemann sums become more exact. Okay, so everything is based on limits. It's a little bit bizarre. Now, what I want to talk about today is how do you do rectangles with a table. So that's what we're going to talk about. How do you estimate rectangles with a table? Super easy. Honestly, easier than trapezoid rule. And then, sorry, I'm looking for my notes. We're going to pause there, and we are going to talk a little bit about overestimates and underestimates. And then we're going to just keep going. We've got some properties of definite integrals we're going to talk about. Those are 3 estimates. So let's talk about definite integrals and tables. We can put it on the back of here if you want it all together. That works, or put it in your paper. It doesn't matter. So let's say we have, yes, Mason?
Whatever is left and right, the middle is the most accurate.
I don't know.
Okay.
Okay. So let's say we have x's and f of x. And let's go to...
Wait, where should I put this on the back of? Which
I
one?
don't care. Where we want. 7, 10.
Put it back on the, I don't know how to say it. Ryman?
Riemann.
Is that a good spot, you think?
Sure. Let's go 12, 15, 18, 17, 15. Okay. So let's start out by talking about, let's say 18. There you go, 18. Let's do a left, and I believe we can do L sub 4 on this one. So left-hand Riemann sum with 4 subintervals. Okay, so what I want you to do is think about how we did this on our graph. The definition of a left-hand Riemann sum is that the height of the rectangle comes from the left side of the interval. So here's your first interval here. So we'll do it like this. There's 1, 2, 3, 4. Okay, if we're doing L sub 4, then our height comes from the left side of the interval. So on the interval from 2 to 5, which number is on the left?
12. Oh, 12.
2. 2 is the x value, 12 is the y value, right? So it's the y value of 12 that we're going to do. That's our height because it's coming from the left side of the interval. And then what multiplied by the width? What's the width of this? 3. Avery and Garrett. So 12 times 3. That would be the estimate of the area for our first rectangle. Then you go to the next one. What y value is on the left side of the interval? 15, because that's the one that's on the left. So 15 times 2, because, and I should have let you say that, 15 times 2, because 2 is the distance between 5 and 7. Okay. What multiplication will you do to get the next one? Yeah. Okay. And then on the last one, what multiplication will you do? 17 times 3. Because these numbers, 12, 15, 18, are each coming from the left side of the interval. So we would have a 17 times a 3. Now, do you have any questions about where I'm getting my 2s and my 3s?
I have a question, but it's not about that.
Okay, just a second. David, what? Yep. Just multiply right out and add them up, and you're done. Like, that's it. Okay? Mason, what's your question?
So you asked for L4, would it ever, because L4 obviously makes sense here, would they ever ask for a number that doesn't make sense, like L3 in this situation?
No. No, it has to make sense. So go ahead and calculate that for me.
I'll do some crazy math.
Okay, what do we get?
171.
171. Okay, now I would like us to find r sub 4. Okay, so same idea. Here's my first rectangle. This time the value comes from the right hand side of it. What's your height you're going to use? 15. Okay, I'm not going to talk you through the whole thing. You find r sub 4. We're talking about that.
So when will we have all the stuff for the online assignment for the big one?
You got it.
We got it?
Oh, yeah.
It has this stuff on it or no?
Maybe. I can't remember. I did it 2 weeks ago. Okay. What do you get for r sub 4?
177.
177. Now, what if I asked you for r sub 2? So sometimes, hang on. So if I ask you for r sub 2, Mason said, will they ever ask you ones that don't make sense? The answer to that was, I still stand by my answer. You can divide this into 2 rectangles. This one and this one. Okay, so I'd like you to find r sub 2 for me.
But you'd never get like an R5 that turns into an R2.
Correct.
is a lot better than trapezoid.
Oh, no question.
So, what is the application that I don't understand why when is it the trapezoid necessary? Or is it just more exact?
Yeah, 18 times 8.
Trapezoid's going to tend to be more exact quicker than right or left hand Riemann sums,
But not
not midpoint. Midpoint's going to be most exact. Okay, so what do you get for R sub 2? 180. We're doing, here's your two intervals. The right hand side is 15 times 6 in this case. I started on the funny side because that's the way I do it. Sorry. And this one's going to be 18 is on the right hand side times the 5. So add those together, it's 180. Question, which of those two is going to be closer to the actual value? R sub 4, because you're more rectangle, it's going to be more accurate. Now, question. I don't know if it's a question or not a question. One of those is not possible. M sub 4, M sub 2. One is not possible.
I'm struggling to see how either are possible.
is there not a middle in one of them?
Sub 4 is not possible.
M sub 4 is not possible. I can divide into 4 rectangles. We know because we did that already. So this is one of my 4 rectangles. I do not have a middle value. Okay. And so if they're going to ask you for an M sub whatever, you have to be able to get the height of it from the table. So you're not going to be like, oh, well, what's halfway between 12 and 15? You're not going to be like, hey, it's 13 and a half. You don't do that. That's trapezoid rule. Okay, because that's what it is. So if you're gonna be asked for an M sub something, you have to be able to divide it into this many intervals where you have a middle value. Okay, so it's okay that this goes up 5 and this goes up 6. They're not necessarily going to be evenly spaced, just the way it is. So M sub 2, I'd like you to find M sub 2 for me. See what you can do. And if you're wrong, it's okay. We'll talk about it.
Ms. Douglas, I watched a video of a guy breaking down calculus using a bouncy ball.
Right.
With like the derivatives and stuff, like acceleration and velocity.
Okay, what do you get for M sub 2?
77.
I got 177, correct. Because here's our first rectangle, right, from 2 to 7. What's his midpoint? What's his height of the midpoint? 15. That's as middle as we get. And I know that 5 is not directly in between 2 and 7, but that's what we've got. It's an estimate, pure and simple. Okay, so middle times 15 times 5, and what else? What's the other math? 17 times 6. So 15 times 5 plus 17.6, that gets you M sub 2. Okay, what are your questions on those? Okay, so set that aside a second. And, oh, look it, we got one of these. The paper I just handed out to you. Take a look at, ignore the top, we're going to skip that. Take a look at this graph right here. Okay, we've got left, right, and midpoint. Yeah.
Which one of those estimates would be the most accurate?
It's probably M sub 4, but I can't do M sub 4. So, just a second, I gotta find it.
The middle one is usually the most exact, but if it has less rectangles.
Right.
I would assume it wouldn't be the left one. Or no.
You can't assume that.
Usually you can't know.
You can't know.
It's because they don't share the same amount.
Correct. Okay, so take a look at this. We've got a function that's increasing and concave up. So you've got 3 pictures there. Take a look at left, right, and middle Left, over, or underestimate? Way under. How about right? Over. So listen, the logic behind this. I'm not going to teach you like how do you figure out what it is. It's too. There's too many things to be like. It's like 5 or 6 things you have to memorize. Don't worry about it. But look, if this function is going up, if this function is increasing, then the left side is always going to be lower than the right side, because that's the definition of an increasing function. And so your left-hand endpoint is always going to be lower than the right-hand one. You're going to have something that is an underestimate. Opposite's true for the right hand. If this is increasing, then on the right-hand side, that's going to be the highest y value in that little interval. Okay? But take a look at the midpoint here. When you're checking midpoints, and you guys, like, you'll get questions like this on my tests, and this is how I always do it. I don't do this. I just draw myself like one big old rectangle. And I'm like, all right, if I did the midpoint on an increasing concave up, is that going to be an overestimate or an underestimate? Yeah. Yeah, I agree. Because what I have here does not make up for what is here, right? So I think that's an underestimate. Say again?
I would expect it to look more like the left and the right hand one. Why does it look like one giant chunk?
Okay, so if I came over here and I drew in my midpoint on a graph of this scale, it's going to be really hard for me to tell. If you scale it big, it's much easier for you to tell. It's going to have the same pattern because the graph is increasing and concave up. It's just easier to see.
So this is like a super zoomed in.
It's just imagine it super zoomed in.
So that rectangle will have the same volume as all those little ones if you drew them a little.
Yes, just imagine that. Okay, so look at increasing and concave down. Okay, so increasing, this is not very good, but if the function is increasing, is your left-hand sum going to be over or under? Under, right? Because you've got, again, if it's increasing, the left side is always going to be lower than the right side, and you're going to come in under the actual value. Same thing's true for the right side. So this kind of illustrates that, what you were asking, Mason. Here's a midpoint on something that's increasing and concave down. It's kind of hard to tell.
I think it's not the same for each of the bars.
I think they're the same. So, but what I was saying is if you were to just be like, hey, I'm just going to ignore their bars and make one big one, it's a little bit easier to tell. Okay? Over or under?
Is that just a random y value you chose?
I went to the middle of the graph.
I feel like it's really hard to tell.
I don't like it. I don't like seeing that. So here's what I'm going to do. I'm going to go like this. There's increasing concave down, and I'm going to draw my midpoint. I shouldn't have made 2. Okay. It's overestimate. Okay. Ignore this. Okay. Because this area here is more than this area here. Yep. So do you see that drawing the picture? Like I said, this is stupid. I shouldn't have drawn it. Draw yourself a big picture on the midpoint. It's got to be big enough for you to see which piece outweighs the other piece. That's why one is helpful and not lots of them. Like you can see these guys because they actually have little pieces over, right? This one, you got to kind of zoom in. So just imagine zooming in on this and just making it big.
So this one is an overestimate.
So overestimate because there's more area underneath here, which I'm including in my area, right? Here's my area. The whole thing. More included in here than we left out. So flip it over. What if it's decreasing in concave up? I don't like those graphs. So let's make something that's decreasing in concave up. Okay, and let's give it 2 rectangles. And you see if you can tell me, is the left going to be over or under? If it's decreasing, right, for the same reason, because if it's decreasing, the left side is always going to be higher than the right side, which means right is going to be under. Look at it. Like if this is my right side, it's way under. This is way under. Okay, so let's talk midpoint. I'm not even going to try to do it on the same graph. Okay, so decreasing, concave down. I'm going to go middle is probably here. Oh, it's concave up. I said it wrong. There you go. Overestimate or underestimate? Underestimate. Okay, and again, let's see if we can think about this. If I can help you out with my thinking, I don't know if it's going to help or not. This is the area that we want. This is how much I'm including that's not actually under the curve, but this way outweighs that, right? Like maybe this much would be the fill-in of that, and I way outweigh that. So this underestimate, sorry.
What is the?
It is. It's just picture drawing.
What is the left one for the first one we did? Could you show that a little bit?
Sure, left is going to be here, right?
Okay, that's why. Okay. I understand.
Yeah. Okay. So decreasing. Left hand is, if it's decreasing, left is going to be under. I don't want you to memorize it. I just wanted to talk about it. So here's how you know though. Increasing and decreasing is what determines left and right. Concavity is what tells you about midpoints. Okay. So whether it's increasing or decreasing isn't going to change the midpoint. It's whether the thing is concave up or concave down. Okay. Let me have you, these are actually SAT questions. SAT, I'm gonna try that again. AP questions. So I want you to try this one. Alex, what's your question? No, you fill it out if you want to fill it out. We just talked about it. Okay, so use a midpoint Riemann sum with 3 sub-intervals to approximate. And we talked about the definite integral symbol. We talked about that last week when I was here. This is AP style wording. They're going to say midpoint Riemann sum with 3 sub-intervals. M sub 3.
We want them to be evenly spaced, right? They have to be evenly spaced.
If it's
right?
possible, right? If it's possible, yes. Otherwise,
You can have it not be evenly spaced and it still works.
the one that I gave you, the one that we did on the back was not. Right? I had one that was 5 and one that was 6.
Yeah, I understand what you're saying there, but I mean like the boxes wise, like how
Yes. The boxes wise have to be evenly distributed.
How am I supposed to get 3 out of this? Am I crazy?
I thought it was great too. It's easily.
Remember that they're touching on one side, right? So touching.
So we just ignore the last value?
No. There's your 3.
You need decimal when you have 2 Caleb? No. Didn't work?
And this would not be on the no calculator portion.
Would this work if it had one more box?
No.
Is this just
Because you can always do one less
This is what we've been doing.
than the number that you have if you're not using midpoint.
Yes.
That's how I remember the other one. But the midpoint you can't. There's no like that.
We're looking for, even though it doesn't say it, is a really good practice to make sure that you give correct units. because the AP will always sneak in there. Oh, by the way, on the score sheet, 1 point for the correct units, even if they don't say it. So just do it.
Oh, because you have to put because it does give us gallons per hour.
Mhm.
Yeah, if they give you units, so just put them on there.
Yep.
And they're probably always going to give us units.
Nope, not necessarily.
Really?
If it's one of the free responses, it probably will. Okay, what is it?
170.
170. Correct. 170 what?
Yeah.
Gallons. Gallons. Because
Absolutely not even close to what I got.
gallons per hour times hours. Okay, so let's talk about it. So in your first rectangle is here. What's the midpoint height? Yep. 13.4. And what's the width of your rectangle? 4. Okay. Your next one, what's the center? Yep. 14.3, also times 4. And then the last one is 14.8, also times 4.
We could have used the shortcut here.
You absolutely could. I did. Could have, because we're talking 4 even intervals, you could have done 13.4 plus 14.3 plus 14.8 and then times 4. That's really just distributive property.
But wouldn't the AP test say that's wrong because they told us that we have to use the.
No, this is acceptable.
Really?
Okay, now I will say this. One of the things that I see when I'm grading these is that they're like, hey, I'm going to give you 1 point for using a midpoint Riemann sum. And the only way that they can know that is if you show your work. Okay, so either the first pink line or the second pink line has to be shown so that they know that you're picking those numbers from the middle. Okay, and I have seen that where that's 1 point, and even if you got it wrong, because you mathed it wrong, if you had that written down and had the wrong answer, you'd still get one of the points. Okay, so it's worth your time to write it down because it's almost always worth 1 point. Okay, flip that over. What? These, or these, right?
Brackets are just a waste of time.
Okay. Also a free response. This one from 2003. We'll try that. It says the rate of fuel consumption in gallons per minute recorded during an airplane flight is given by twice differentiable and strictly increasing function R of time t. Blah blah blah. I want you to find. Here you go. The integral from 0 to 90 with 5 sub-intervals indicated by the data in the table. That just means use the stuff in the table.
Why would they give us the graph
I don't know. If you want to use the graph, you can. Just make sure you realize that you have the actual values there. Okay, so I want you to find that. Do the left Riemann sum, which is going to be L sub 5. Which, by the way, it's totally fine to use that as your label when you're like, hey, L sub 5 is this. And then I also want you to answer that last question.
Alright. Whoever came up with vertical tables like this is evil.
I know it's harder to think about what's on the left and what's on the right.
Well, the good thing about this one is at least it's not if it's midpoint it would be harder.
Yeah.
Well, maybe it wouldn't be. I don't know. But I think midpoint's harder because you can't just know how many you're supposed to have.
You know what I mean?
I like it better if you know. So when we make our rectangles, we have to break them up depending on how many like entries there are, not based on the value of the entries.
Correct.
So like, it doesn't matter if each number is
Correct. Correct. It's how many you have. And so like that first one jumps from 0 to 30. Too bad for us.
Box is just gonna be a big box.
It's just going to be a big box.
I did not get I got one.
3,700?
I got 1,750. 3,700. What? I got 1750. Yeah, I got 1750. 3,700. Yes. I mean, you're not the only one who's got
3,700.
Oh, I did mine from the right.
Oh,
I did.
Wait, I did mine from the left though. Taylor, what'd you get?
Come on.
I got 2,600.
Oh, never mind.
I got 3,700.
I was
3,000 or 2,000. Look where he's standing.
3 every time.
No, I'm saying, how do you say a 3? Mason, I'm saying, I don't know, but you saw how far away.
Controversial apparently.
Just a well-hydrated one.
Um,
That's what you said.
what'd you get?
3,700.
1750.
I got 5,300.
What?
No one got.
Okay.
Oh.
Okay, so let's talk about this.
The very first one you throw away. The very first one you throw away, it's times 0.
What? No.
No.
It's a lot.
It's the change.
Okay. No. It's 20 left.
20 times 30.
That's the Y value.
This is the Y value on the left. So 20 times 30. So listen, let me say this about the vertical table. I had to do this for my brain to turn it at least the first couple, right? So 0, 30, 40, 20, 30, 40, and be like, oh, it's the first number in the set that's the left-hand side. So this is going to be 30 times 10, 40 times 10, 55 times 20, and then 65 times 20.
Which I have that exact number and I got 3,700.
If you flip that say with the Y, I think it's 1750.
3,700 gallons.
It went, yeah, it went like this.
Yeah, I don't know how I got my thing wrong. 3,700, and it is gallons. Now, here's the question. Is this less than the actual value of the integral from 0 to 90?
Yes.
Why?
It's increasing.
Because it's increasing. So I would say on, like, if you're on the AP test, then you say on an increasing, is the approximation less than? Yes, it's less than because this function is increasing, which means that always the left-hand value is going to be the lowest one in the interval. Okay, here's what I would like you to do. We're going to be picking and choosing homework from random places. I would like you to do this page. I want you to do number 1.
It's right below or is it? Oh, right below.
Number 2 and number 3. Okay, I'm not done though. Oh, I just said I'm not done.
Guys, no calculator.
Okay, in your other packet that you already have.
Did you say, wait,
1, 2, 3.
1, 2, and
1, 2, 3.
I can smell it.
the homework 4.3B thing?
Yep.
4.3.
Okay, you may cross off B. 3B.
Thank you.
Welcome. And then go back to the fatter packet, right?
Yep.
You have a fatter packet.
4.3 number 2.
Yep. Nope. Okay, so there's one before. You've got this guy, right? Well, one page before that. It says trapezoid rule. Okay, I want you to do number 3. This is a different paper, Avery. Avery, the other packet. Yup.
And then that's it.
Nope. Turn it over. I want you to try. It's still the fat one. 7.
Try our best on 7.
Yup.
Yeah, that looks not
Is that the bean?
Just the bean. And then flip it over. And I want you to do. Oh, stop it.
I'm not gonna remember all these. I'm like,
Why aren't you writing them down? That's not my problem. That's a you problem. I want you to do 7 and 8.
Can we go over the skinny packet again? What was-
Yep, hang on.
It's 1, 2, 3.
1, 2, 3. Yep.
Okay, I'm gonna try and get the skinny packet done all right now. So
Okay, so 7 and 8 on the fat packet. Flip it back. 7, the kidney bean. You're doing the bean. And number 3. Okay, and then 1, 2, and 3 in the skinny packet. Very, very reasonable assignment. Not change anything today.